So periodic function is any sort of function that repeats itself and repeats the sort of regular pattern of y values. And you see them all over the place in real life. So hopefully a periodic function for you is your heartbeat. It's repeating itself regularly with time, unless you have some sort of an arrhythmia or something like that. Other periodic functions that involve height might be like a child on a swing or tides. There you're seeing the height of the child is going up and down at a regular rate with time. Same idea with the height of the tides, right? Going up and down at a regular rate in step with the moon. We see periodic functions in physics all the time. So any kind of a wave is a periodic function. So a light wave is an electromagnetic periodic function. So an electromagnetic wave has an electric field and a magnetic field that are both oscillating back and forth periodically. So they're oscillating back and forth at a really, really fast rate, but that has a periodic nature to it. Same idea is true of a sound wave. You've got, if it's a sound wave in air, you have little tiny air molecules moving back and forth really, really fast, and that's what actually creates the motion of your sound wave. Your utility bills, if you were to graph the cost of your utility bills over time, you would see probably a periodic nature to them too. Maybe not perfectly periodic, but you would see the cost of your utilities go up in the winter when heating costs are more expensive. And then your utilities bill will go down in the summer, right, when heating gets cheaper. And then that will repeat itself from year to year. So that makes it periodic too. So looking at a graph, this first graph here, this one is not periodic. The reason why it's not periodic, even though it has some sort of up and down nature to it, is that it's not repeating any sort of pattern here. In fact, this one looks a lot like a damped oscillator, which is maybe like a child on a swing who's trying to slow down and get off the swing. So they're going back and forth, but they're not reaching the same heights ever. Like they're getting smaller and smaller and smaller, and eventually they'll stop and get off the swing. So it's not repeating itself in terms of going all the way back to the same heights or same original pattern. This one here is periodic because you can see there's this little pattern here. The pattern goes like this. And that pattern piece will repeat itself perfectly, and then again, and then again. So this one is periodic. This one here looks like maybe someone bouncing a basketball. It definitely looks periodic. The basketball goes up and down, and then follows the same pattern, so that is periodic. This one here looks like it has a pattern to it, but it's not repeating the same pattern. It keeps on going up and up and up and up, higher and higher and higher. So this one is not periodic here. So you have to repeat the same y values to be truly periodic. All right, so what is the period of a periodic function? Well, period is the length on the horizontal axis for the cycle to repeat itself. Just a heads up, for physicists, the horizontal axis will always be time if we're talking about a period. We call it other things if the horizontal axis is like a distance, like an x, we would call it the wavelength. But mathematicians are a little more flexible on this, so they would let anything on the x-axis or the horizontal axis, any sort of repeated pattern they would call the period. But in physics, we actually have more specific names for different x-axes. So the symbol for period in general is capital T, and usually you'll see it with units of time, but sometimes you'll see other things in math. So usually that'd be things like seconds, maybe hours, maybe days, that kind of thing. And how do you actually measure period? Well, it's the length of time for the pattern to repeat itself. So one way is you could start maybe at the top, the highest point, and just wait for the pattern to get back to that same point. That would be one period, and we measure that on the time axis. How many seconds went by for that to happen? But I could have actually measured this differently, right? I could have actually also started at the bottom and measured, well, how long does it take for me to get back to the bottom again? That's also a period there. And I didn't have to start from the bottom either. I could have measured maybe starting from the middle. And if I go up and down and back to the middle again, that is also one period. How much time that takes would be a period there as well. Notice those are all the same length of time. So you can measure the period from really anywhere on your pattern, as long as you're looking for how long it takes to go back to sort of the beginning of the cycle again. So you're looking for the length of time of just one cycle. That's what your period is. Amplitude, that's the distance from the middle line or the midline of your cycle up to either the highest point or down to the lowest point. So here's the middle of my function is just halfway in between the max and the min. And then the amplitude is how far from that line to the top. That's A. Or you could say how from that line down to the bottom. Those are the same distance because the line is halfway across. It has a symbol A. And you can actually calculate it with an equation as well. So the equation is the maximum height minus the minimum point. So that would be like the highest point here. That's y max. Minus the lowest point, that's y min. Divided by 2, right? So the distance between the highest and the lowest point, but then just half of that is what we call the amplitude. So divided by 2. The units of amplitude are just whatever is on your vertical axis, so whatever's on the y-axis. So they could be anything at all. Let's try a little example of that. So let's say you're graphing blood pressure, a person's blood pressure over time. So times in seconds here. There's their blood pressure in milligrams of mercury. And the first thing we want to know is the period. So for that, I'm looking for how long until this pattern repeats itself. Well, it kind of starts here, goes up, has this funny little dip, and then it looks like it's going to repeat itself about here. So how much time has passed until I got back to the beginning of the cycle again? That would be the period, so capital T for period. And I can actually just use my graph to measure that. So each one of these boxes, if this is 1 second here, each one of these boxes must be a 1/6 of a second. That's a 6, sorry. So there's 1/6, 2/6, 3/6, 4/6, 5/6. So 5/6 of a second is the period there. For the amplitude, there's kind of two ways to do it. You can do it just directly from the graph. Just erase some of this stuff here. So you can draw a middle line. This is the midline. That you can see is just falling halfway in between the highest point and the lowest point. And then the amplitude is the distance from that midline to the top, or from the midline down to the bottom. And you can notice from your graph, it looks like each of these boxes is 10 milligrams of mercury, right? So I've got 1, 2 boxes, so it looks like 20 milligrams of mercury is my amplitude. Or you could use your formula. Amplitude is the maximum point minus the y value of the minimum point all over 2. The highest point you ever reach up here is 120. The lowest point this graph reaches is 80. That's over 2. So I have 120 minus 80 is going to be 40 here on top, all over 2, which is 20 milligrams of mercury. All right, we can also figure out things like what is the blood pressure P at a specific time, maybe 1. So for that, you would just look at 1 second here. Try and look at what is the y value there. It looks just a little bit above 110. So maybe you have to estimate this from your graph, but maybe like 112 milligrams of mercury. And let's say we want to know maybe at what times is the person's blood pressure 100. So for that, I would look at, well, here's 100 on my graph. And you can see that happens at this time, and this time, and this time, and this time. It's going to keep repeating itself. These are a little bit awkward to estimate, right? But if this is 1/6, it's a little bit less than 1/6. So maybe like t is point, I don't know, 1/4 seconds, maybe roughly. Little bit less than a half here, maybe 0. I don't know, 4 or 5 seconds, and so on. So you're just kind of estimating from your graph there. The last thing we want to learn about is frequency. Frequency is how many oscillations happen in 1 second. The symbol for it is F, and the units are 1 over time units. And if time is in seconds, then that means the units will be 1 over seconds. Then the units of frequency, that's a comma, sorry. Then the units of frequency are 1 over seconds, and the short form for that is a hertz. So you'll see hertz as the most common unit of frequency, which just means 1 over seconds. And period and frequency are related with this really lovely equation. Period is 1 divided by the frequency, or frequency is 1 divided by the period. What this means is that the frequency is how many oscillations are actually happening in 1 second. So if you think about like a pendulum swinging back and forth, if the pendulum has a period of half a second, then it swings back and forth 1 divided by a half, or twice in a second. We'll look at a few examples next. So here's a pendulum. Let's say it has a period of a quarter of a second. Then the frequency is, well, how many times is it actually going to swing back and forth in 1 second? If its period is a quarter of a second, we know intuitively it should swing back and forth 4 times. Let's use our formula. So F is 1 divided by T. So F will be 1 divided by 0.25. Oh, sorry, that's 5. Which is indeed 4 hertz. So this means the pendulum is swinging back and forth 4 times in 1 second. When you get into sound waves, frequencies get a lot faster because sound waves have pretty high frequencies. So middle C on the piano has a frequency of 256 hertz. So that means that when you play a middle C on the piano, you're hearing your little eardrum is that you're hearing that sound from. It's actually oscillating back and forth 256 times every second. So, and the little air molecules as they're transferring the sound from the piano to you are moving back and forth 256 times per second, really, really fast. So how long, what is the period of just one oscillation? Well, that would be 1 divided by 256, which is 1 divided by 256 is 3.9 times 10 to the negative 3 seconds. So in that very short amount of time, the air molecules will oscillate back and forth.